Hey, what's going on? This is another daily math training with Khan Academy. My name is Chris. Today we're going to be working with algebraic expressions and combining like terms. In these videos, I try to just quickly, refresh my memory with basic mathematical concepts, going from basic arithmetic all the way to advanced calculus. I'm currently trying to prepare my mind for mathematical computation, particularly for graduate school. I'm really interested in computational science, computational social science, machine learning, computer vision, and ways to kind of put these things together for teaching people how to learn things. So my idea isn't really fully thought out. Like, it's not really thought out pretty well right now, but I do know that consistency is a key. And every day I find myself motivated to work more on myself in these in these particular drills and routines. So I'm gonna just quickly take care of this right now. I usually spend like 20 minutes, doing it. And once I'm done, I'll share my camera and talk a little bit more about it. But I also, in the future, I am looking at probably taking these videos and maybe breaking them down into something that's easy to, I guess, review or reference in the future. So I'm going to go ahead and move on to the first video, well, first question. So here, combining like terms with negative efficiency. We have some questions here. All right, so we have negative 4y minus 4 plus negative 3 in parentheses. It says combine the like terms to create an equivalent expression. So we're just going to create an equivalent expression. So on this side, we can have the equivalent expression. So what we need to do is we pay attention to order of operations that we learned last few videos ago. I don't know, maybe like a month ago. So we have negative 4 plus negative 3, which would be the first thing we were trying to work with. So I think we have positive times negative is a plus times a negative, right? It's a negative. So we can go ahead and we can bring that out. So we bring that over here. I'll just drag that over. Yeah, that'll be easier to do. And then we're stuck with negative 4, right? So this would basically be negative 4 minus negative 3. That's like adding. So it becomes like a negative 7, right? So we can go ahead and put the negative 7 here, and then we can have 4y. So it'll be 4y, negative 4y minus 7. All right, here's the next one. All right, so here we have combine like terms to create an equivalent expression. Negative 3z minus z. So negative 3z minus z, I'll put these little slashes in a minute so we know it's not a 2. That's how I like to draw it. And then we know that this negative z is pretty much like a 1z. So then looking at it, without looking at the z variable, we could just look at it like this, where we know it's, once again, it's the same thing as negative 4, because negative 3 minus 1 is negative 4. And then we can just put the z back. And we get negative 4z. All right, moving this one. Combine like terms to create an equivalent expression. All right, so we have 5k plus negative 2k minus negative 1. All right, so let's go ahead and look at it. We know that we say negative times a negative, we get a positive. So we'll get a positive like that. Remembering our order of operations, we get that. And then we have 5k plus 2k. So we have different coefficients here. And this is a variable. These variables are the same. So that means we can add these. First, we're going to go ahead and say positive times negative is a negative. So negative 2k, and then you have 5k. So 5k minus 2k, that's what we could bring down here. So I'm just going to redraw this. Let's bring this down here. Let me see if I can Oh, let me. Let's try this again. This is 5K plus negative. Nope. Yep. So let's get that in there. Negative 2K. Negative times negative is a positive. Make sure I remember that. All right, so we have 5K minus 2K, which is basically like 5 minus 2. We're going to get 3K, and we have plus 1. So this is it. So this expression I made here when I combine like terms is just the same as that. 3K plus 1. Final answer. Okay, next one is if 8t plus 1 plus 4, negative 4t plus negative 6. All right, let's quickly get this taken care of. We have 8t plus 1 plus negative 4t plus negative 6. So what we're going to do is that we're going to look at this piece here and this piece here because these are pretty much similar. This is a 4t, right? Let me draw it up here where you can see what I'm doing. I'm going to put this here. I'm going to go here like that, and we want this one. So we know that this is a positive. So we can go ahead. We can say 8t. We're going to, say plus times negative is a positive. I mean, plus times a negative, like positive times a negative is a negative. So we get negative 4t like that. And then we will do the math where it's going to be 8 minus 4, which is going to be living for 4t. And then we have the next one where we're going to take this term and this term here, remembering that we're going to take this positive times by this, we're going to get negative 6 on, and it'll be 1 minus negative 6. So 1 minus negative 6, this is kind of like saying I have negative $6 and I have 1. So it goes up to negative 5. Oops, let me just change this. It's supposed to do this. Whoops. Yeah, like that. So it'll be 4t negative 5. 4t minus 5. Not negative 5, but yeah. All right, so we move to the next one. We have here combine like terms to create an equivalent expression. Trying to draw it out. All right, we have negative 12 minus 6p minus negative 2. So first what we're going to do, we're going to just put the 12 here, 6p. Okay, so first we want to basically focus on is we have this piece here where we're going to go ahead and I want to do it. So take that and yeah. So we're going to turn that into, that's negative times negative will be a positive 2. So we can take the 2 out of the parentheses, and then we can bring the negative t right here. And now we have 12 plus 2. We can do this now, which is pretty much like I have, $2 in my bank account. And this is weird. So if I have $2 in my bank account and I want to buy something for $12, so I don't have it. So I'm going to end up negative. So it's going to be negative 10. Okay. So that after we get the negative 10, now we could just put the 6p here because where would I put the 6p? I would put the negative 10 on this side. And that's just me, with a rough guess of how I would do it. I don't necessarily know. This is actually right, but we're going to try it out. Okay. So I'm going to get negative 6p minus 10. Negative 6p minus 10. And I didn't get the little negative on the side. Here we go. So we make sure it's matching. nice one. All right. Combine like terms to create an equivalent expression. We have this equivalent. We have this equivalent expression here. We have k plus 3k. So both we have the k's here, right? Remember that. We also know that we have this 1k here, right? And we have this plus 3k. So this is pretty much the same thing. You know, this is, we can actually make this expression make more sense to us. So that's negative 1k plus 3k. So that's kind of like where I'm looking at. The other thing is, trying to make sure. So right now we have negative 1 plus 3. That's kind of like where we look at. Don't even pay attention to the cage just yet. We're just going to look at this. So now what we're going to do now, we can just say we want to buy something for $1 and we have $3 in our bank account. Whenever we have an expression like this, an addition expression like this, on this side is like what's in my bank account. And out here is like what I want to buy, you know, because whatever I'm going to buy, it's going to take away money from my bank account. So I say, so basically it's also like saying this, you know, because of the negative on this side. Okay, so I'm going to go ahead and do that. So basically we end up with 2K. Okay, the last one here we have 4r, negative 4r minus 2r plus 5. And says combine like terms to create an equivalent expression. An equivalent expression is the same expression. So we're going to put 4r minus 2r plus 5 on this side. And we want to make this, we want to make another expression on this side, which is equal to this one. So one way to do that would be negative 4r minus 2r plus 5. So this is basically saying negative 4 minus 2 plus 5 and negative 4 minus 2 plus 5. This is a really good question. So we have negative 4 minus 2 is basically like saying, it's like saying you have negative $2 in your bank account and you want to buy something for negative $4, you know, and that is pretty much like saying negative 4 minus 2, which would be negative 6. Like you don't have it in your bank account, remember? So we would get negative 6r, or we put the r back now. And then we have the plus 5 because since there's no other variable, like I guess this would be called, this is called the coefficient. This is called the constant. And because this doesn't have an R on the side or any other letter, we just place it over here like that. And it even keeps its, you know, positive sign there. So we'll just say 6R, let's bring back we have plus 5. All right. And we can complete that. All right, so now we have that. Well, how are we doing on time? Now we have 14 minutes. We can go jump to the next one. All right, we have 4 questions here. Now simplify it to create an equivalent expression. All right, so let's just move this over to the side like this. Like that. And we're gonna start doing the math on the table, on the screen. So if it's negative plus 8 and it's negative 5r minus 2. This is also PEMDAS, you know, order of operations. We're going to start with working on the numbers on the with the parentheses, but because because we have this expression here, and this is like a it is a multiplication expression. Multiplication. I'm sorry. It's a multiplication. It's a multiplication expression using the same combining like terms system. But what we're going to do is we're going to multiply. We're going to start off with, taking the -4, negative r here. We're going to put the negative r over here. And there's a way to do this. I would want to do, you would probably want to just start multiplying positive 8 times -2, which would give us -16, right? And then you would have here negative r times -5. And there's a thing about when you multiply, when you're multiplying these r's like that, you actually are getting, you actually are adding. So, and I'm trying to remember why. I can't remember exactly why, but I feel like that's what it would be. The other thing is because we're not, is this the actual equivalent number? So in order for us to make sure, in order to see if this is actually true, I'm going to actually run some tests right here on the screen. All right, so we're going to plug in r equals 1 into all these here. So we're going to make this 1. We're going to make this 8. We're going to put 5, -5,192. And then we'll solve it, right? So we have -1 plus 8 would be +7, right? And then we inside here we would have -5 times 1 would be -5, right? Minus 2, which would be, I have, -$2 in my bank account, and I want to buy something for -$5, and I end up with -7, right? And then you have, so then we end up with, let me go ahead. Then we go ahead with -7 times +7 times -7, which is -49, because the negative times a positive is a negative, right? So then we know that if we plugged in -4, if we plugged in r equals 1 into this expression, we're going to get -49. So that means that if r equals 1, and with this expression leads us to -49, then one of these have to lead us to -49 as well. So that means, so now we can try that. We can go ahead and we can try to see if we plug in 1 in one of these. And which one should we start with first, Well, let's start with the A because we were already working with that one, right? So we have -6r, right? Times 1 would be -6. And then you have a -16 here. So this is kind of like what we had before. We have -$16 in our bank account, and we want to buy something for -$6. You end up with -$22, and that's not, that doesn't equal that, So let's go ahead and look at the next one. So we have here, if you plug in -1, you have -6r, right? Would be -6 minus 2. The same thing with -8. Then we have this one, -49r. We added -1, right? -41 times 1 would be -41. And then if you minus that by 2, that'll be, you're adding that, be -43. No, yeah. Now, and then you have the -41. -41r minus 16 is, it doesn't look like it's going to work. So we have negative 41 times 1 would be negative 41, and we have minus by 16, negative 57. So this doesn't work at all. We don't get the same expression at all. So it doesn't look like I can actually plug this in. This is not going to work at all. But that's okay. We're gonna sit back here and we're gonna figure out which way is actually, a good way to do things. Simplify to create an equivalent expression. Let's go ahead and look at the hint. So we're going to distribute like we were going to do before. We 8 here goes into the 2, you get 16, you get the R here because it's 40, and then you get an R here as well. So I actually distributed it wrong. So we ended with negative 41R minus 16. So in order for us to plug in these numbers properly, we have to distribute the numbers first. So let's go ahead and look at the numbers, meaning that when it's time for me to go ahead and have that, and then we actually put the negative 2 here, we get negative 16, and we get this negative R, and then once we do that, we know negative R plus 40R minus 16. We know that this is the combining the like terms of this particular expression. So it looks like what happens is that the variable outside, this variable, this negative R, doesn't get put in there at all, even if it's a 1R. That's interesting. And then, or maybe it could be done. It should be able to be done right now. Okay, sorry. It is being done. So once we get this over here, then we add this. We add this negative R, so it's like a negative 1R, and we get negative 41R minus 16. So if I would have added 1 in this particular situation, I would have gotten that. So the plugging in the 1 cannot be done yet. You can't do it until you actually plug in the numbers properly. That's good to know. All right, let's move on to the next one. All right, so here we have simplified to create an equivalent expression. Now we have the other one we were going to do before, right? Where let's go ahead, let's move this over to the side. Let's move into our numbers. We're gonna go ahead and we're gonna start doing the first one with a negative 2. Goes into this, which will be negative 12, because negative 2 times 6 is negative 12. And we have negative 2 times negative 5 is negative 10. If we on this side, we can do a negative 5 times 2. It's going to be 10. And then we have positive 5 times negative 7 is 35. And then you have then we have these two systems here. And you have negative 10 minus 12, which is negative 22. Can still hold those on the side. Negative 39, 7. And then we have negative 22 plus 10. I think we can leave this right now. We could just leave this and see what we're going to do afterwards. Now we have like something we had before, right? Like the original way we're doing it. So we have a negative 22 plus 10. So we can just turn this into a negative 12. And then we have minus 35R. No, 35N. Um, hmm. Did I do that? I think I multiplied something wrong. Let me see. Right, I didn't put this. Yeah. Yep. Okay. So we have here negative 5n plus 6 plus negative 2 minus 7n. Let's try this again. We're going to go ahead. We'll take this. Here we get negative 12 on this side. Here we get negative 10n. Forgot to do that. Then I'll leave this in parentheses and add a plus here. We'll go negative 5 times 10 is 10. Negative 5 times here is 35n. Now we'll do this where we negative 10n minus negative 35n. Right. I see what I did, right? This is actually a positive. Yeah, it has to be a positive because we have the numbers down there that show us that. Then we have this one here is negative 10 plus negative 12 plus 10 is negative 2. So we get this, and it looks like they have the expression like this, where it says negative 25n minus 2, which will be this one. Okay. All right, let's go ahead and keep moving. All right, so we have here negative 3z minus negative z minus 2. So it has here negative 3z minus z in parentheses minus 2. This is going to be negative 2. It's going to be a positive z. And then we'll get a positive 2 here. I hate, why would they do that? I'm going to put a chorus in here like that. I got to just make this a little bit better because that looks horrible. All right, I know that, so we have plus z, and I put the little slash in there, and then this is 2 like that. And where I know that that's what we're looking at. And then we have here negative z, right? Let me go ahead and just quickly clean this up. Okay, so now we take the negative 3z plus the other z here, and we will, remember, we're going to get negative 2z and have minus 2. So it's the only one down here. Oh, the only one down here is this one, B. Okay, I made a mistake. We might have a sign error. Let me see what I did. Right, that's what I did. I distributed this over here, but I didn't do it to this one. That's a very tricky thing to do. You gotta make sure you pay attention to that. All right, next one we have here 2 minus 6 minus 5t plus 1, and then you have negative 6. Let's go ahead and distribute this. First, we're going to distribute these two. So a negative 6 times negative, no, well, that does that work? Yeah. End up with negative 30t. And then we have negative 6 over here times net positive 1. I'm going to get a negative 6. And then we will get, I think we just leave the 2 alone, right? Yeah, we just leave the 2 alone. And then what we do is that we get 2 minus 30t plus minus 6 like that. And then we'll take the 2 positive 2 here, subtracted by the negative 6, we get negative 4. We get negative 30t like this. And we should, that should be this. Yeah. Okay. So that's that. Thanks for like watching. I was like, one thing about this particular combined like terms is that the methods to putting things together is very, it's the distribution property. You know, whenever you have like, if you have a number outside of a parentheses and you have to multiply it, you have to distribute that number over across every single term that's in the mathematical expression. And then you have to make sure that you're writing everything properly, so that way you can, when you go back, you don't miss a decimal or something. Or you can even slow it down even more and solve it completely and cross it out. You know, just checking after yourself is actually really important, and it really helps with learning how to do things. So anyway, thanks a lot, and I'll see you guys in the next video.